Okay, let's practice here with definite integrals. So let me share screen. The ones that are going to be on the quiz, they will not involve U substitution, not yet. Okay, so we have just our basic standard power rule. Okay, increase the power by 1, divide by the new power. That would become x cubed. But then when I divide by 3, I'm going to get 2x cubed, right? Since 6 divided by 3 is 2. And then antiderivative of 5 with respect to x is 5x. No need to put the plus c because that would just zero out. And then the step that's new to us is having to plug in these values. Okay. And according to the fundamental theorem of calculus, this is solved by finding capital F of 3 minus capital F of 2. Capital F stands for the antiderivative. So what I just found up in here, this expression is my capital F. Okay, so I plug in. So let's see, 2 cubed, or well, I'll plug in and show all the work, I guess. Not do steps in my head so people know where all the answers have come from. So there is F of 3. Okay, then I have to subtract what I get when I find F of 2. All right, so that's 2 times 2 cubed plus 5 times 2. All right, and you won't have your calculator, so I promise not to give you horrible arithmetic. So let's see, this would be exponents first, remember, not multiplication. Exponents first, then multiply. So 3 cubed is 27 times 2 is 54. Plus 15. 2 cubed is 8, minus 2 is 16. So minus 16. And then this will be 10. Notice I'm distributing my negative. Well, let's see. This gives me negative 26. If I put these together, I don't know. I'll just go left to right. So let's see. That's 69 minus 16 minus 10. And if I'm not mistaken, that leaves me with a grand total of 43. Okay, so your answer in a definite integral is a number. Okay, and this number represents that if I were to have taken that, so let's see, that's a parabola, up 5 units, right? Because this would raise it 5. The 6 would make it grow bigger faster. So it looks like this. And if I looked at the area under that curve between 2 and 3, right? So I'm looking at this area, the amount of area that I would have there bound by the vertical lines at 2 and 3, and the curve itself and the x-axis. Those are the boundaries of this region, and the amount of area in this region would be 43. So let's do one more. Okay, so this one, and I'm going to put right in the directions that leaving answers in exponential form or as the sum or difference of 2 fractions is a perfectly acceptable way to leave your final answers. Okay, so how do we apply the power rule on something like that? Okay, and I hope we got good at this back when we were just doing basic integration, right? We bring it upstairs. That's x to the negative third. I haven't integrated yet. That's why I've still got my dx and my integral symbol. Okay, I've just rewritten it to put it in the right form where I can apply the power rule. Okay, then the power rule says increase the power by 1, divide by the new power. Okay, so if I increase that power by 1, I would get x to the negative second and then have to divide by -2 and plug in 1 and 4. So I don't want to plug in when it's in that form, right? This was why I really stressed with you at the time. We always leave our exponents positive, right? We bring them back downstairs and leave them as positive values. So that -2 doesn't move, although I like the negative sign out in the front. Okay, so I'm going to put it in front of the expression. 2 will stay downstairs. The x squared comes back downstairs. All right, now I'm ready to actually plug in. Okay, so I'm going to plug in. So this part right here is my capital F. Okay, right here, capital F. Okay, so I'm going to do f of 4. Again, you don't have to write f of 4 minus f of 1. I'm doing that as a way to show my work step by step so that no one gets confused as to what I'm doing. Okay, so you don't have to write this step, but go to capital F, which is right here, plug in 4. Again, make sure you do order of operations, right? Exponents first, then multiply when I simplify this a little bit. Minus f of 1. Don't forget it was a negative, so I'm going to have a negative, a minus, minus here. Oh, let's see, 1 squared is just 1. Okay, so when I go to clean this up just a little bit, so I am going to let you leave your answer as the sum of difference of 2 fractions. But notice here, let's see, this would be 16 times 2, so -1/32. How about we make the minus minus into a plus, and then 1 times 2 is just 2, right? So we get here. I'm content with this as an answer. Although certainly this would be a place where I think you could very easily, right? These are not difficult fractions. I think you could very easily get a common denominator, and you'd get -1 plus 16. So you'd actually get 15 over 32. Okay, so there's no reason I think that any of you couldn't do that fraction work, but I say write in the directions on the quiz that answers that are sums or differences of fractions are acceptable.